uh, or their programming language, and the Python. These are with the basic programming language, not actually the basic, the complex programming language for statisticians, or the other data scientist, or other data scientist. Now, there are a lot of similarities between these two languages. Between these two languages, you can focus on either one language. You can focus on either one language and leave the other. Let me share my screen with you guys so that we can do MBCD and what we are supposed to talk about today. I think you have loaded the commands that you are supposed to use today. Cindy, in your machine. I shared, I sent them in your group WhatsApp. Cindy, have you loaded those commands in your R Studio? Or we can load them together. Cindy, Jenga. Jenga.
Yes.
We will review your the SQL after the class. Because I've
Okay.
asked, yes. Have you downloaded the commands that we are supposed to use today?
Yes, I have downloaded the command and also installed the program, the R.
Okay. What about the R Studio?
Yes,
Okay.
I have also installed it.
Ladies in the group, Scholar, not the Sendia. Sendia Moiro, do you have the software with you?
Yes, I do. I downloaded the R Studio.
The R Studio together with the R Sendia.
Yes.
Okay. I think I can. Yesterday you were introduced on the interface, the GUI of that particular software, and today we will just do data analysis there, and together with the programming part of it. We will be doing programming, then we do the data analysis to demonstrate how that language understands the data. Or rather, we do data analysis to understand the patterns that aligns with our data. Uh, let's open the R Studio. Let's open the R Studio. Okay, I can share my screen with you. Let me share my screen with you and wait for others to, as we wait for others to join us. This is my R Studio. Okay, this is R Studio. This is R Studio. The commands here for online day 2. Let me. Actually, this will be your project. This will be your project, and the first project. This will be your first project. Now, I'm sure you are directed on how to install the packages. You are directed on how to install packages in R. Is it true? And this is the GUI of R Studio. Here we have. This is where we write the command. Then we have the output. Then we have the plot. Then this is where our variables are saved. From there you can do the packages here. You can install packages here, and you can import files here, do ABCD here. I want, as we open the commands for day 2, Okay, one may ask, why is my R Studio or as this color? As this color. So you can change the background of your R Studio if you wish. You just click on tools. After tools, you click on global options. So you click on global options, then you can see we have appearance here. We have appearance here. When you click on appearance, you can choose one from these files here. These are appearances. So you can choose appearance of the appearance that you like most. So mine, I'm using a vibrant ink as my background color for this particular software. Okay, let's continue. My recording screen is very small, so let me see whether we have that option. Yes, so cancel. Okay, now I want us we open files from the tool. I shared the files, the commands with you. So you click on files, or even before you click on files, you can open it directly from your machine. So the bounty analytical. So I shared the is here. Let me check. Okay, this is it. We have it here. So after downloading it, you can just click. You can just click, and then you have the commands with you. This is the online day 2. I'm sure Mr. Bill told you that we have the operators in SQL. We have operators in Python. These operators now we are taking them where? We are taking them to our programming language. What is a logical operator? I want to hear from you. What do you understand by the name logical operator?
Sir, I have a question first.
Yes?
How do you do it without going to WhatsApp or opening that file without going to WhatsApp?
Okay.
Download it.
I think it's in your machine, senior.
I'm just inquiring. How can you do it without going to WhatsApp to open it so that you like what you have done there?
Oh, like what I've done, let me show you how we do about it. You can click on this one here. Okay, let me answer your question in this simple manner. The file is already in RMD format, that is, or in R programming language. So when you open it, any application of R that is stored in your machine will be responsible for opening it. So for example, if I give you a Word document and you don't have a Microsoft Word in your machine, you don't have a Microsoft Word in your machine, will you be able to open that particular document, Joseph? Will you be able to open?
I'm not getting what you're saying. I'm just inquired, how do you get that file using RStudio, not going to WhatsApp to extract it?
Okay, let's assume this file is in your machine because I shared the file through WhatsApp. Sawa. I shared the file through WhatsApp. Sawa. Now, let me show you here. You just click on your WhatsApp, on your PC, I mean, not WhatsApp. From WhatsApp now, you click on down, from your PC, you click on downloads. So. Because I shared the file, and you need to have it somewhere. You can see I have it on the online day2 file here at the downloads. So because I shared using my phone, and this is my laptop. So this is the folder where my file is. When you try to open it, when you double click it, it will automatically be opened by RStudio. Have I answered your question, Mr. Joseph? Is your question answered, Joseph? Okay, let's continue with what we are supposed to cover today. You will notice that logic operators Okay, I wanted one of you to tell us what is a logical operator, but now I can see the time is not on our side. Now, Mr. Joseph, are you okay now? I want to hear from you before I proceed. Okay, we can continue from there. Operators. Let's start on this part here. No, this is a list. Let's start here. Not operator. So this is the programming language of R. So this is the programming language of R. Now, when you say that let our list 1, I think you will not. Were you introduced on vectors? Okay, let's start from the most basic parts. I assume that no one has a prior knowledge of this programming language. When we want to store some data in R, we store it in vector form. So we store that particular data in vector form. Are we together? We store that data in vector form. For example, while we are here, let's say we know that marks of students, this marks he has scored 5 marks in 5 units. Now, we have a function that we call C. C function in our programming language is used to store data in vector form. Please understand that. So, when we want to store these marks in this programming language now, we cannot say marks is equal to 20, for example, 20, that 29, for example, 3, 4, 5. We cannot say marks is equals to 20 marks, 30 marks, 29 marks, 40 marks, 45 marks, 39 marks. We have not stored that data in this programming language. Now, remember, you will be required to call these marks somewhere else and get or return these particular values here. Are we together? For you to store this data, you have to store in vector form. Now, what is the syntax for storing that particular data in vector form? We say marks is equals to, we use C function to store the data, then we store everything inside what? Inside brackets. Inside the bracket. So inside the bracket. Are we together up to that point? Now, when we have this one here now, we can execute that command. When we execute this command, we expect the output to be stored or to come out here. Then we will have these marks stored under what? Under data here. So hapo unaona we have the global environment. So these are the commands that I have been running from last week, I think. Yes. Now let's try to run this command. For example, when you click run, what happens? You will notice that we have marks here and a global environment. It has 5 numbers. This is number from 1. It has 5 entries from entry number 1 to entry number 5. What are these particular entries? We have 20, 30, 29, 45, and that's 7. Are we together up to that point? Then from there, you can see what we have here is marks is equals to this. So when I call out marks, what do I get? I expect to get these particular values direct here. So let's try to call these marks here. For example, when we call this particular, then you click run. When we call that particular marks, you can see what we have is a vector of these particular entries. Do you have any question up to that point? I want us to go step by step so that any student is not left out. Patricia, how are you? Are you grabbing the concept? Okay, nani hajaelewa? Was not understood how we store data in R?
I'm fine.
Okay, are you practicing what we are doing?
Yeah.
Okay, very good. Jenga,
Yes.
can you store data now in R?
I have not yet opened the file.
Pardon?
I have not yet opened the file. It's not opening.
Do you have the R studio with you?
Yes, I have it.
You can share with us your screen so that we may help you. Hatutaki uachwe nyuma, si ndio?
Yes. Okay. I'm using my phone. Then doing practically with the laptop. It's not connected. It's not connected to the internet. So
Okay. I think you can execute this simple command that we are writing because we have not even started doing those things on the content.
Okay.
So.
Yes.
Okay. David. Mr. David.
Yes.
Can you store something in vector form in R?
I have stored and then executed Then I got an error, object marks not found.
Okay. Just to share with us your screen.
I think I'm also having a similar challenge because I'm using two laptops, listening on one and the other one executing.
Okay, this is the problem you are encountering. You are trying to call Max, but Max is not found. Senior.
Yes.
Because you have not executed the first command, which has Max is equals to C, then blah blah blah, something inside. That's also.
Okay. If that's the case, then I'm good.
Yeah. So you just put your cursor here, just anywhere in that particular line, unaweza weka katikati or anywhere, then you click run. When you run it
has what?
You have these things here, then you can call that particular item that you are executing, then you get the answer. Sindio?
Just what?
Yeah, that is it. Now, let's do this, something that we are calling a logical operator. You remember very well, we were using the greater than, equal to, select, where salary is greater than 10,000. Those signs for greater than, less than, equal to, those are the operators that we are going to use. But now, every language has its own or unique what? Unique operators that it uses. So, for example, you will note that we didn't use this sign anywhere in SQL, but we will use them here. Now, we have list 1. List 1 is a vector of logical operator. You will note that in logical operators, in our programming language, we have the symbols and we have the true and false statement. So, a true statement is a logical operator. So, is a logical operator. So, I will this command here do. So, this is an element-wise logical and operator. For example, when we execute this command here, when we run that command there, you will okay, another thing, this sign here, the hash, are used to show the comment or to display the comment, so that when you are executing, the compiler will not execute anything that is on right from that particular symbol. So from that particular symbol. So now, when we execute this command here, for example, check this. When we execute list 1, when we call list 1, we have 1 and 0.1. Remember, this is the 0.1, we have it here, but now 1 is for the logical operator true. For the logical operator true. You will notice that when you are writing the word true, it will change to a specific or a different color from other ones in the RStudio compiler. So the first is number F. We can start with, for example, T. For example, T, you can execute the T and see what you are getting is 1 and 0, or T is for true. T stands for true, and F stands for false. So we can see what we have here is now false assigned 0. False assigned 0. But now let's continue with our true statement. When call this particular, we can have the 1 and 0.1. That is an element-wise logical operator. So that is element-wise logical operator. Another thing, we have the complex numbers in this particular language. We can have list 2. List 2 is just something that I'm calling list 2. You can return even your name. You can say your first name is equals to this, but now I've decided to use the list ones. So list 2 is equals to C, you store 0, and 4 plus 3i. This is the imaginary part here, for example. So let's see. I have stored my list 2. So you can call list 2 and see what you have. We can call list 2 and see the numbers. You can see what we have here is we have the 0 real part and 0 imaginary, and the other number we have 4 and 3i, this part here. So there we have not included the 0i here, but it's captured, it has been captured in our compiler. Now this operator here, I want you see the operator that we are going to use to combine these two lists. So the comment is any non-zero integer value is considered as a true value, be it be complex or a real number. So when we combine, this is an AND operator. And what operator? Okay, we have combined this part here. Where's the list 2? I want you understand this part here. We have combined this part here. We have the imaginary, the true value, and we have zero number here. So we have the real number here, and we have the imaginary part here. But when we combine these two, which logical operator are we going to get? So any non-zero integer is considered as true. Any non-zero what integer is considered as true. We have this true here and this true here. Those are non-zero integers. So be it be complex or real numbers. So this part here, when we combine this part here, from list 1 and list 2 here, we get the true statement. But here, this is a true, and the other one here is a 0. So this is a 0. So the output should be false. You cannot combine a true logical operator with a 0. So do you have any question up to that point?
Yes. My question is said that we need to have online day 2 uploaded.
Yes.
Which I have already uploaded. And I've tried to run what you have been doing there, but I can't see those lists.
Is it possible you share with us your screen?
Unless I can, let me connect.
Okay, connect, then you share. So. Another with the question. That is the AND operator. This is the AND operator. So we use this sign to AND the two lists. So. But now we can have the element-wise logical or operator. We can combine the two lists with the OR. Combine this together with this. So how does this OR operate in this programming language? You will notice that here we have this sign here stands for or, and we can return this command here will return true if either of the operands is true, if either of the operands is true. So now this is true. This is we have the imaginary part here. See that? So when we execute these two commands here, for example, you will note that the element-wise logical or operator will return true if either of this part here of list 1 or list 2 is true. Then that is when the compiler will return that part to be true. So this is just the programming part of it. Then we will dive on the data analysis. So how do we apply that? The OR operator, we print list 1 or list 2. We print list 1 or list 2. What are the attributes or what are the values that are stored in list 1? Under this one here, I want to hear from you guys.
Nice.
Yes, Mr. Joseph. King Mula. Okay, let's continue. We have the not operator. Not operator is presented by the exclamation mark. This one here. The mark that you are getting from that part. This is it. How does it do? Or what does that operator do? A unit operator, it will negate the status of elements of the operands. So for example, list 1 is equals to 0 and false. This is true part, this is false part. What happens when I negate those two, the two values in that particular operands? It will just be true. So it will just be true. Remember, okay, pardon, I'm sorry on this part here. This is false. So this is false. Is the letter 0, the number 0, is it true or false? Is it true or false? I want to hear from you. I want to hear from you. This is false, Bona. This is false. That's why we have, it's just getting the opposite of what is in list 1 here. So what is the opposite of list 1? What is the opposite of false is true. So that's why we are getting this true output here. So any command that you execute here, you should get an output here. So you should get an output there. Then those particular is on the vector that will be stored on that part. We have the double logical operator and the logical AND operator. We have the two signs here. This will return true if both first elements of the operands are true. If both first elements of the operands are true. What happens here? We have the first element as true. We have the first element as, for the part 2, as false. When we combine those two, we will definitely get a false statement because we don't have a true value here on list 2. We don't have a true value on list 2. But when we insert something that is not 1, that is not 0, for example, let's see what you will get. You can see what we have is true. What we have is true. Now from today henceforth, just know 0 is regarded as a false statement in our programming language. So what we are doing, we are just learning the operators, the basics of programming language in this part. We have the double logical operators. We have the double or logical operators. Let me see. Yes, we are here. These operators, they will return true if either of the first element of the operands is true. So okay, I want one of you to tell us, even before we execute this command. This command here, the printing output commands, will return true if either of the first element of the operands is true. We have a true statement here and we have a false statement here. What do we expect here? When we have the double OR operator here, this is true, this is false, and the return is, it will return true if either of them is true. And you can see we have true here and we have false here. So only the first element. Don't consider the second element. What do you understand will be the output, or what do you think will be the output? This is true, this is false. The comment is very clear here. It will return true if either of the first element of the operand is true. So yes,
It will be true.
It will be true because the first element of the list 1 is true. So because the first element of the EB is true. Now let's do something else. We have the relational operators. These are the operators that we were using in SQL. So I'm sure we are very familiar with these particular operators. The less than operator is the same operator used here in this particular language. So it will return true if the corresponding element of the first operand is less than that of the second operand. Else it will return false. What do you understand by this part? It means your compiler will return a true value if the element in your first operand here is less than that of the second operand. So now we have true and false. So don't be confused here. Between true and false, which one is less than the other? I'm sure this will confuse you just for now, but you will understand. So this is a true statement. This is a false statement here, which is 0. So now I'm asking my compiler, is list 2 greater than list 1? Is 0, is false greater than true? Is false greater than true? Is false greater than true? Let's see. False, as far as R programming is concerned, false and true are two different logical operators, but the one that is considered to be greater than the other is the true. So we don't expect false to be greater than true. That's why we are returning what? We are returning false here. So we have 0.1 and 0.1. These values are equal. These values are equal. So none of them is greater than the other. So that's why we are getting false. But if we increase the first one to be 0.2, for example, we expect this part here to be false, because 0.1 is not greater than the 0.2. So but when you increase this one to be 0.3, for example, what will happen? We have true. So 0.3 here is greater than 0.2 here. So or if you insert 1, a whole number, let's use a whole number 2 is greater than 4. 2 is greater than 4. Let's see. You execute those commands. No, 2 is not greater than 4. That is why we are getting false. So another thing, in programming language with R, you will note that string values. Let's go back to the data types. String values, they are quoted using this marks. So they are inside the quotation marks. So they are inside the quotation marks. So now in listing and using these less than operators, when you want to compare the string values, what compiler does is it compares the first letter of a string, the first letter of string. For example, in list 1, it will compare the first letter, which is A in alphabetical order, as compared to B. So are we together? We expect
Yes.
A. Yes, I can hear someone with a comment. Now we expect A to take number 1 in alphabetical order. So we expect B to take number 2. So it is true that 2 is greater than 1 using this alphabet. That's why we are returning a true statement. Are we together up to that point? Yes? Yes, Malvin. Your sound is a little bit not audible.
I'm saying you can repeat it once more.
Okay, let me repeat. But remember, we have to do a lot of things here. So you can see where we have commands here, and we just have 1 hour to go. Now we will do marathon. Then you just go through those particular words, those particular comments, and each command. Then you will understand what we are doing. So we have less than or equal to. We have less than or equal to. Here we have it here. this operator will return true if the corresponding element of the first operand is less than or equal to the second operand. So else it will return false. So else it will return false. Is true less than or equal to false? No. Is 0.1 less than or equal to 0.1? Yes, it is true. We expect true. Is A less than or equal to bat? Yes, it is less than or equal to. So now, is true. Remember, true is biggest. So true, is it less than or equal to false, to a false statement? No. No. That's why we have false, true, and true statement. Yes. So remember, for the strings, you consider the value assigned to the first letter of each string value. Then you compare those values and you execute these particular commands. Then you are good to go. For the greater than, the command is the same, so you can check this at your own time. For the greater than and not equal to, we use this the exclamation mark together with the equal sign. Then we return this command will return true if the corresponding element, it will return true if the corresponding element in first operand is not equal to the second operand, else it will return false. I think the meaning is very clear. So now, it is true that true is not equal to false. Yes, that is a true statement. That's true. Is it true that 0.1 is not equal to 0.1? No. We expect to get a false statement. Then we expect the other one here to be true. So yeah, because we don't expect 1 to be equal to 2 in alphabetical order. So we get true, false, true. So now let's demonstrate those particular things now using what? Using data. Using data. We have vector 1, which is a vector of 0 and 2. We have vector 2, which has 2 and 3. When we execute this command here, what do we get? We have vector 1. We can see we have vector 1 has been loaded. We have it here. We have vector 1 there. Then from there you execute the second one on your cursor is on the second line. You can see we have them here. So these vectors, they are formed of what? 1 row and 2 columns. See there? 1 row, 2 columns. You can see it's just 1 row, but we have this column and this one. That's why we have 1 and 2 there. That's how we range what? We range vectors. So this cat performing operations on these operands now. Cat command is used to display. Please get this point clear. Cat is used to display a string that is not in our operation. So a string that is not in our operation. For example, when we execute this command, we see that vector 1 is less than vector 2. You can see we don't have cat here, but this cat here is a function to display what? To display what is inside here, a string that is inside here. But now, when we apply this, the less than vector 1, the less than operator here on vector 1 and vector 2, on vector 1 and vector 2, we are telling the compiler to check if 0 is less than 2. Yes, it is true that 0 is less than 2. That's what we're getting true here. Is 2 less than 3? Yes. That's why we are getting what? True statement here. So we can check on the second one. We cut vector 1 less than or equal to vector 2. This vector is less than or equal to vector 2. Remember the output or the syntax for returning less than or equal to. Well, then we execute this command here. It is true that this vector, the 0 is less than or equal to 2, and it is true that 2 is less than or equal to 3. Simple. Yes, it's just that simple. But will vector 1 be greater than vector 2? Definitely 0 is not greater than 2, that is a false. 2 is not greater than 3, that's a false statement. So that's why we are getting false and false statements. Greater than or equal to is 0 greater than or equal to 2? No. 2 is not greater than or equal to 3. So we expect those output to be false. The other one is not equal. So this is not equal. Vector 1 is not equal to vector 2. 2 is not equal to 2. 0 is not equal to 2, and 2 is not equal to 3. It is true 2 is not equal to 0 and 3 is not equal to 2. Those are true statements. Those are true statements. Are we flowing together, Mr. Jenga? Scholar, are we together?
Yeah, we are much together.
Okay. I think this language is very simple. It's simpler more than the Python. See there?
Yes, I totally agree. I wish you have started with this one.
Okay. This language is very simple. It's simpler than Python. Python is you go and save files, file under this file. But R is very simple. By the way, if I may ask you, what is the difference between these two languages, the R and Python? Who can tell us the difference between those two languages? Who want to try? Do we have IT guys here with us? The developers. Okay, I think I can tell you the difference, huh? Yes, John, why? Are you an IT guy? I want IT guys to tell us. Yes, engineering, I want IT. Okay, I understand you now. I understand why you are saying that. You will note that the main difference between Python and R is that Python is a general purpose programming language. So you can apply Python in so many areas. But now R is a statistical programming language. R is a statistical programming language. So what does that mean? It means that Python can be used for a wide range of tasks, like the web developers. See there? Yes, let me see. Very good. That is the difference. See there? So engineering guys, I know you are not in the field of statistics a little bit. You do very minimal, if I'm not wrong. just small statistics. So, but now Python will be very very good for you when you want to come up with what? With the softwares for engineering. For engineering, you can do all those things. So that's just the difference. Do we have statistics, guys, here? Do you have statistics? Anyone doing statistics or economics? Make sure you understand this language well. So,
We are here. We are here.
okay. Now, Kabila, let me tell you. When you graduate, after your graduation, make sure this language is on your fingertips. Getting an employment, let's say for example Safaricom, they will write a script for our language, for example, then you use it to do some simple analysis in their databases. So R is for you, statisticians or data analysts. Okay, let's continue. I'm not demoralizing the other language, but I'm putting emphasis on what I know, because basically I took statistics as my course. Okay, let's continue. So the assignment operators, these are the assignment operators. Here you can see the assignment operators. They are used to assign values to various words, to various data objects. So the assignment operator, for example, when I say vector 1 is equals to when I say vector 1 is equals to C, then I store 1. That equal sign is the assignment operator, for example. So that is the assignment operator. Then we can use I think you can check here at your own time. This is a very straightforward comment. So that's a very straightforward comment. We have the right assignment. You can assign vector. This is equal. This is a right assignment. Now, when we talk of right assignment, you will understand that we have assigned vector 1 here. The vector 1 is A, B, and true statement. So this the right assignment. We can use these signs here, all a single. So we can assign everything. We assign them to right. So the vector 1 is assigned these values here. For the left assignment is the same. You can have it here. This is the left the left assignment. Yes, the left assignment. So for example, this is a right assignment. So for left assignment, I'm expecting to have something like this. So now I'm expecting to have vector 1. Vector 1, I assign it to the right. See there is C. We have AB and true. So and true statement. That is how we assign from left. That's how we assign from left. This is how we assign from right. So this is how we assign from right. We have the miscellaneous operators. These are just mixed operators that simulate the printing of sequence and assignment of vectors, either left or right. Either left or right. We can have vector 1, for example. Here we can have this operator here. I think these things are very straightforward. When we apply the this sign here. This is the percentage in percentage operator. It will check if the element belongs to the list and return Boolean value true if the value is present. If the value is present, else it will return false. Else it will return false. For example, when I say val is equals to 0.1, and I say list 1 is equals to true 0.1 and apple. For example, I want you to be very keen here. Print val, this 0.1, remember val is the same as 0.1 if it is in list 1, if it is in this particular list here. So now, then you can return it. It is true that val 1 is in this list. But what happens when I change this val to 0.2 and I execute the same commands? It will be a false statement because val which is 0.2 is not present in list 1. Is not present in list 1. So that's how we check with the miscellaneous operator to check if certain values or certain values of a vector are present in the other vector. We have the colon operator. It will print the list of elements starting with the element before the colon. For example, when I say print 1, the colon 5. So I expect my compiler to print what? Numbers from 1 to 5. But if I print the first, for example, I will ask you, print the first 10 values in a list. So then you can click on run and execute those commands. So we have another operator here, the miscellaneous operator. The percentage operator. What does this operator do? This is a matrix. This is a formula for forming matrix in R. When I say mat is equals to matrix, this is a function. This is a function inside what? Inside our programming language to trigger, to direct the compiler that the values that we are going to store inside here, they will just be forming matrix. Then from there you specify the number of rows. I want 2 rows and n call 3. So mat is equals to matrix, then you open brackets, you store C. C is used to store data in vector form. But now here we are changing vector form to matrix. So I start from the first 6 numbers from 1 to 5, from 1 to 6 I mean, comma, number of rows I specify 2, comma, n call 3. N call means n number of columns. Then I execute this command, and what I have, I can print the mat now. Check print mat. Print is the same print that you are using in Python. When I print mat, I'm printing this now. So I have executed this command here. My command has been executed, and everything has been saved. Yes, the file has been saved somewhere there. Then you can print this column, the matrix, and you see those particular matrices. When you say print T mat, what does T means? It means the transpose of matrix. What is transpose? Transpose is rows becoming columns, or columns becoming rows. So that what is the transpose of this matrix? 1, 3, 2, they form the first column, the second column. So yes. What happens when I say pro? This is just a product of pro is anything. Pro is not no. This is just a function here. I'm assigning everything here to be counted pro so that I can print that pro next time. You remember that this is my matrix here. This is my matrix here, there. The T matrix is here, and from there I can multiply. This is the same as multiplication. So percent star percent is multiplication. I have multiplied them. Then from there I print the pro and check these are my output. Those are my output. Are we together up to that point? And you know, when you try to use multiplication direct, you will not get that particular. You will get an error. So this is non-conformable array as far as this language is concerned. So you have to use what? You have to use this particular sign. Then you execute the commands and get those things. From there, we can do something that we call a function. Let me check. Okay, a function. So allow me to be a bit faster because the time is not on our side. So what is a function? In R, a function is just an object, so that the R interpret is able to pass control to the function. So you can read the comment at your own time. I want us to go direct to the function. When we say print a sequence of numbers from 32 to 44, sequence is a function in R. Sequence is a check the word sec is a function. When you bring your cursor here, you will note that we have something here, something is popping out. It means this is just a function inside what? The R programming language. Sequence of numbers from 32 to 44. You can print those numbers at your own time. Mean is a function. Mean of numbers from 22 to 82. From 22 to 82 you can come up with those numbers. So the mean is 53. You can say print mean X, where mean X, or print mean amount, print mean salary. So if you have those data in your data set, we can sum numbers from 41 to 68. We can sum those particular numbers. You can see the output is. So now these are functions. So those are.
I have a question.
Yes.
Is that print sequence 32, 44 the same as the one?
Pardon?
The one that you have done above?
Yes.
You print, then you put colons. Is it the same?
Which one?
Hiyo ya hapo yenye umeandika print, then brackets are 1 to 5 with the full colon, then number 1 to 5. Is it the same?
Okay. Yes, it's the same, but now I'm inserting some functions inside. See, for example, I want you to check here. When I say print, see there, print 1 to 5. So when I say print 1 to 5, I have those values there. See there. Do you get the point? But now inside this I can insert a function. See there. So I open another bracket here. I can have the sum. Now sum is a function. See there? Sum is a function. I'm adding everything from 1 to 5. So
Okay.
yes,
Okay.
that is it. From there you can define now a function inside a function. For example, use a defined function. You can define your own function. So for example, creating a function to print square of numbers in sequence. Square of numbers in sequence. Let's say you want to define a function in a function, not in a function. We want to define a simple function. So a function for how do we get area of a square is how do we get area of a square? Area square. See there? Area square. Area is length times length. The length are equal. So the area is a single area, then you square it. Now you can have this function here. So my new dot function is equals to. So remember this the meaning here is the same as equals to is equal to function of a. When you define a function, you use the curly bracket. So you use the curly bracket. You have a function a which is made or which has values from 1 to 3. So my I can be taking values from 1 to 3. Then I can define something inside it where b is equals to I, then we square that particular I. So it can be any value. So then we can print b. But now instead of printing b here, we enclose it and we have our final what? Our final function here. I want to click on this function, this bracket here, and this is a function, a simple function inside this big function here. So when we execute this command here, what we have is just a use and is just a function. We have defined a certain function. So we have defined a certain function inside a function. But now what happens when you have okay, this is the programming part of it. So we want to do examples here and done ones. So another thing, you can call a function with arguments by positioning and by names. We can create a function with argument. For example, we can have a function that is defined by 3 elements or 3 entries, a, b, and c. So which is my results should have letter a times letter b times plus letter c, for example. Then I can print what? I can print the result. Remember the result is defined here, and this one here, this bracket here are defining this function. Now we are calling this function with argument of values in different positions. So when you execute this command here, what do we get? We get those particular commands or those particular function being defined. Now we can call this function by inserting some values direct. My new function here, remember my new function now, I want it to have the values of 5 as a, 3 as b, and 11 as c. I can call function with this value. See there, I have my output direct here. So or you can interchange them. You can call these functions by their names. Here the compiler understands that all takes these values and assigns them direct to these particular values here. But now you can specify When we change and we say that this was A, 3 was B, and 11 was C. What if I start with A11, B5, C3? Will I get the same answer as 26? Let's see. Let's see. The answer must be different because remember how I have defined my function inside here. It is A times B plus C. But if here we had a multiplication, we would get the same answer. So the compiler is using what? Is using the BODMAS. From there you can call a new function. So new function is equals to, you can define any function. For example, in your project, the first project that you will do, you will have to write a function for calculating area of a circle. So you must define everything inside here. You can call a function with the default argument. For example, you can create a function with what? With argument. You can create a function with argument. Let's see. You can have a function where you are defining your argument direct, where you have the values of A is equal to 3, B is equal to 6. Then you define what you want your compiler to return. I want my compiler to return what? A function is obtained from a result of A times B. Then print the result, everything inside the bracket. Then we can return that particular command. After that, remember, when you execute while your cursor is here, you are executing only this part from here up to here. So that's the reason why when you click here, you will notice that even the other bracket is becoming active. Now when you execute, you are executing just the inside part without the other part. But now when you call the new function, now you are executing what? From here up to here. So you are calling that part. So we can execute this part now and return those particular entries, which is 18. We can call the function by giving a new value of the argument. For example, so we call the function with giving new values of the value of the argument. Or before we continue, are you grabbing any content? Are you grabbing any content? Mr. John? I want to hear from you. Mary. Yes, John?
Yes.
How is the function, this part of function?
Yeah, the part is good. Yeah, personally, I'm getting. Yeah,
but what?
The file that I have opened, it doesn't have it.
Okay, I will sort you. I will do your so. Benson. Mr. Benson.
Yes.
How is the experience with this part of function?
It's quite challenging, but we'll get used to it, I think, with time, with practice.
Okay, very good. Scholar, I want to hear from you.
Yeah, I'm okay.
Okay. I think now for you to be in good position, you have to do more revision. See there, you can do more revision. It's when you are the first time you are tackling or you are encountering with such commands, then unatulia tu. You have to do more research, sharpen your mind well, so that you can define any function. So imagine on Friday you will define one function or two. See there. So I think you will get you will get you will get what you are supposed to get here. Okay, let's repeat here. We can call this function by changing this value, for example, here. But now, when I call this function, the new function here with the brackets only, it means I'm calling the new function with the default value that has been defined in this particular function. So. But when I call the new function, for example 905 here, it means the values that I'm going to use here, the values that I'm going to define inside here is 9 and 5. So let's execute and you see that we have a different value. So that is 45. This 45, because when we multiply 9 by 5 we get 45. Okay. Lazy evaluation of function. Argument to functions are evaluated lazily, which means that when means so they are evaluated only when needed by the function body, or treat a function with argument. For example, when we create a simple function here of a and b, for example, and assign it to one. This is our new function, which is a function of a and b. I print a squared b a squared, then print a, then b. So this value here will just return, will just decode or return the values of a and b. Remember, we have not called what? We have not called the function yet. So when I have executed this part here, I have executed from this only that part. So when I call the new function as let's say for example 2. Now when I execute, when I insert 2, what will happen? Will 2 be a and b? A or b? Will 2 be a or b? Unapata hapa the b is missing with no default. But when I insert here 1, for example, it means my compiler has now assigned b value what? Value 1, and I have the output here. So that is how we go about that. The other part is loop. The other part we call it loop, and in loop this loop is just a control statement that will allow multiple executions of statements for a set of statements. So the one looping means cycling or iterating. So we have the types of loop in our programming language. We have the for loop, we have the while loop, and the repeat loop. So we have the repeat loop. For the loop, for loop syntax, the first one here, the syntax is very simple. for, then you open the bracket for values in, let's say, a certain sequence. So then you define the statement that you want for this particular loop. This is for loop, and R programming are programmed to demonstrate this language or this loop using the loop, using for loop. When we have a vector x here, for example, which has values 2, 5, 3, 9, 8, 11, 6, for example, we can count which is equals to 0 for values in x. So values in x, in this particular x. What do? We now put our statement. Which is our statement? We want to count these values if our values are starting from 2. 2 is our first point of count from this x. Remember the operators. Go ahead and check the use of this double percentage operator. Then we count is equals to count, then we increment the counting by 1. So for example, from 2 we increment by 1, from 3 we increment by 1. That is a function that we are calling what? A loop. We are doing something inside here, but we will return everything at the end of it. So when we execute this command there, we can print the count values. Let's check count not found. Let's check why. Debugger task 2. What is missing in this code here? So return print count. I think I will
is that count supposed to be, is that count supposed to be count equals count plus 1, or is it count dash count plus 1?
This one here.
Yes.
Count, remember, count we are starting from something that we are calling count. Remember, count is assigned the 0 entry. The first 0 entry. From this part here. So we are starting to count from count, then we increment it by 1. This part here. I think I will add more. I will share with you the console for loop, because I can see I end only one here. So then we will correct this code and demonstrate for loop using another code that you will understand more. So we have the while loop. While loop will execute some calls until a logical operation or until a logical condition is met. So for example, you can count while x is in range from 1 to 5. So when x is 6, you stop counting. So the syntax is while you insert your logical operator. From the logical operator, then you write your code. For example, factorial of a negative integer is a multiplication of integers from the values from that number to 1. So in mathematics is denoted by the exclamation marker for factorial. So for example, the factorial of 3 is 3 factorial, which is 3. C dot 3 3. So 2 the same. Note that the factorial of 0 is 1. I want us to do of if I want us to check. We have while, if here, and we have while. So this is a loop of while and loop. For example, we have a factorial r, which is a function of x. This is a function that has been defined to this what? To this function factorial r here. What is happening inside this factorial? We have some operations that are happening. If our x starts from 0, this is equation, this is assigning x to be 0, then we redistribute the 1, else what will happen? Else redistribute xy, x is greater than 1, then rest is x minus 1. This is the count for the factorial count. So while x is greater than 1, what do? We open the rest, which is equals to x minus 1 times rest. Remember, factorial we multiply by factorial. For example, 5 factorial is we move from 5, 4, 3, 2, 1. That's why we are reducing x by 1, then we multiply by that residual, the one that is remaining. Then we have the x, we equate it to that number, which is x minus 1. From there we can return the residual, then the factorial. For example, here factorial 8, let's see, we can see factorial 8 is this number here. When we have factorial 0, we expect to have 1, for example. This is a for loop, a while loop. This is a while loop. So you can do more research. For example, one of you may not understand the syntax for the factorial. For example, if you are not a mathematician, and you want to apply that part in your what? In other fields. So you can do more research on how you, with your area of specialization. If you are a teacher, you can do. If you are an engineer, you can do research on how do we apply this in engineering. How do we apply factorial while operating some plants, some machines, or doing ABCD in your area of specialization. But you understand factorial. For example, factorial of 1 is 1. For the factorial of 5 is 5 times 4 times 3 times 2 times 1. I want you to multiply, to do this factorial now, using the values from 5 to 1, factorial of 5, where you start with values. You define those values direct. You define those values direct. So we have another example here. We have another example here. For example, when you assign n to be equal to 0, I think you will understand with this. When we have n is equals to 0 and the square is equal to 0, and square is equal to 0. While loop, we can use while loop now to return what? To return this particular square here, the square here, but when this particular square, when this square is 300, our process of calculation will break. Our process of calculation is supposed to break out. Are we understanding that point? I want to do square of numbers until I get, for example, 300, but 301, I don't want something that is giving me 301. So while loop will terminate the process if square is greater than 300. So remember, n is n, which is n plus 1, the increment part of it, and square is n squared, this n squared. Then we can return n and square. What happens when we execute this command? Yes, we have executed that part. N, for example, n3. Let's see here. Let's define what? Let's define n here from n3 to be 8, for example. Then you execute that part. Then you execute this part inside here. Who is getting the, are they on the same boat? Who has any concern up to this point before we continue? Yes? Any concern as we continue? I will share more notes on this. This is just a start. So I will share more notes. Then we will be in good position so that you may understand more. You can sum vectors. This is sum of vectors. Yes, I want to execute these commands up to, this is a repeat loop function. Let me terminate it here. So the syntax for loop for this one is simple. So remember what we are doing here is the programming part. So we will I will give the real analysis problems using this while loop, because you have understood that what we have here is just programming. These are just this is programming part. So I will share with you the real world problems where we apply those particular loops. For example, for a repeated loop, you can repeat print, for example, x, break statement to terminate if x is greater than this one. So print x if x is greater than 7, for example, then break. So this is just the analysis part. Increment. Let's check on the increment. Increment x by 1. X can be x plus 1. Then from there you can have x which is equals to 1, sum is equals to 0. So we repeat. What are we repeating? We are repeating sum, where sum is equals to sum which is 0 here. Then we add x. Remember the value of x was what? X was 1. The value of x was 1. So the value of x was 1. So the other part is for print sum. The other one is for incrementing x by 1. So I think that was what we were supposed to cover today. And before you close your machine, make sure you understand or you have grabbed a knowledge on how you can save data in vector form. Another thing before we continue is, now imagine you have a lot of data from somewhere. How do you import those data in this platform, in this software called the RStudio? I will just show you the process of importing, then we end the class there for today. So you just click on files, you import the dataset from base or from AR render from Excel. When you click from Excel, you will be prompted to show what? Your file where you have stored your data. I want you to click on browse. I want to import any data set. For example, this one here. I know I will get an error importing because I have not executed the right what? The right command. Not the right command actually. The right package that is responsible for reading those data sets, also for reading the data files. But actually what I wanted you to do is to download a package called render Excel. Even if we import, you will not be able to import it now because you have not called that particular. So that we may continue tomorrow without some problems, I will urge you to import that particular file. You just click on import file on tools, you can just come here on the packages, then you import from that part.